Hello, students. We're studying a new section, section 7.1. We're going to begin by finding the greatest common factor and factor by grouping. So just so you know, this chapter is about doing the reversal of what we did in the previous module. The previous module, we took parts and we built bigger parts, basically. It was like playing with Legos, and we had all these parts and we built them into a big structure. Now, in chapter 7, it's like we have the structure, but they want us to break them back into their original parts. And so it's kind of decomposing or deconstructing that we're doing. We call that factoring. It's finding out what the original factors were. And so we're going to start today by just talking about the greatest common factor and learn to factor by grouping. So we're going to find the greatest common factor of a set of terms. We're going to factor polynomials by finding the greatest common monomial factor. And then we're going to practice factoring polynomials by grouping. So the step for finding your greatest common factor. Find the prime factorizations of all integers and integer coefficients. Then you're going to list all factors common to all terms, including variables. Then you choose the greatest power of each factor common to all terms. And this is, the word common is important. Every one must have that same factor. And then we're going to multiply those together to find our greatest common factor. If there's no common prime factor or variable, then the greatest common factor is 1. So here we have the numbers 30, 45, and 75. If we were to prime factor them, 30 is 2 times 3 times 5. 45 is 3 squared times 5, and 75 is 3 times 5. So we're going to look for the ones that they have in common. Now, if I look at this 2 here, is there 2 common over here in this one or this one? No. So I'm not going to use a 2. How about 3? Is 3 a common factor? Yes. And how about 5? Is 5 a common factor? Yes. Now, you're going to pick the one for our exponent here. Unlike when we did the lowest common denominator, you're going to pick the lowest termed one that they have in common. So this one does not have a 2. I mean, this one has a 2, but these guys don't. So we can only take that which they have in common. So we're just going to leave it a plain 1. This one has a 5 squared, but these two only have 5, so we can only use 5. So the greatest common factor is 3 times 5, which equals 15. Okay, so 15 is the factor that goes into both of those. 15 goes into 30 twice, 15 goes into 45 3 times, and 15 goes into 75, I believe it's 5 times. So now we're going to do the same thing here. Let's find the greatest common factor of 20x to the 4th y, 15x to the 3rd y, and 10x to the 5th y squared. So 20x to the 4th y is the same as 2 squared times 5 times x to the 4th times y. 15 is the same as 3 times 5 times x to the 3rd times y. And 10 is the same as 2 times 5 times x to the 5th times y. Now, if I look at this carefully, I have a 2 here, but I don't have a 2 here, so I can't use the 2's. So then I go on to the next thing. What about 3's? Can I use the 3's? No. How about 5's? Yes, they all have a 5 in common. They all have an x in common, and they all have a y in common. But we're going to take the lowest exponent in any of them. The lowest is x to the 3rd, so we're going to use x to the 3rd, and the lowest here is y. And so our answer is, and the lowest on the 5 is, they're all to the 1st, so it's 5x to the 3rd y is our least, or is our common factor. Okay, greatest common factor. All right, how about 6n and 30? Even though they're in a binomial together, we can still see if they have factors in common. 6n is the same as 2 times 3 times n, and 30 is the same as 2 times 3 times 5. So what do they have in common? Well, they each have a 2 in common, and they have a 3 in common, and that's about it. So their commonness is really 2 times 3, which equals 6. So we could factor out, so their greatest common factor, GCF, equals 6. Okay, and then we're going to do an additional step with that. So once we've discovered that it's 6. We're going to divide it into each one of these. And 6 into 6n leaves us with just n. And 6 into 30 leaves us with just 5. It's like we're undistributing. If I distributed this, I'd get back to here, wouldn't I? So I'm undistributing. That's what we're doing, is we're undistributing. We're breaking it back down into its factors. So if one of the factors was 6 and the other one is n plus 5. Okay, so undistribute. Okay, and this one, there's x to the third, and then this one is x. So they both have an x, but the lowest exponent is just x. So that's what their common factor is. If I factor that out, if I divide that by x, this becomes x squared, and this becomes a1. And then you can see by redistributing it, I would get back to here. So we've undistributed, and this is what we get. Okay, how about here? Start to see what some factors are. Well, it looks like 5. What's the greatest common factor between 5 and 15? Well, it's 5, isn't it? And they both have x's, and the smallest one is x squared, so we're going to put x squared here. What does that leave? 5 factors out the x. What does this leave here? It leaves us an x, and over here we get a 3. And if we distribute, just to check that we did it right, 5x squared times x is 5x to the third. 5x squared times a negative 3 is a negative 15x to the third. And so we have undistributed right there. Okay, here is another one. 2x to the fourth minus 3x squared plus 2. Now, I am not seeing anything that really says to me, oh yeah, that's it. I can see a common factor. So we're going to do something a little unique here. It's called factor by grouping. And they're going to show us a little bit on how to do that. There's no common monomial factor other than 1 in this case, right? If we look here, 2, a 3, a 2, but they have to all have a 2 or all have to 3. They don't. And they don't all have x's. So there's nothing that they have in common except for the number 1. So we would just say that there is no GCF. How about this one? Well, in this one, because they're all even numbers, I know there's at least a 2. And there is also an a. In fact, there's an a to the second. So I'm going to factor out a 2a squared. And so when I do that, what's the leftover stuff? Remember, I'm really just dividing each one by 2a squared. Well, that would be a negative 2a to the third. That would just leave us a, and this one would leave us at minus 6, or minus 3, sorry. 6 divided by 2 is 3. If we distribute it back, we get back to here. So if we distribute, it takes us back to this answer. But we're in the process of undistributing by finding the greatest common factor. So if you have a negative coefficient, you could also have factored out, instead of a 2a squared, we could have factored out a negative 2a squared, and that would have left our leading coefficient in our leftovers positive. And that's what we really want to do. So if your leading coefficient is negative, always factor out a negative with it. Well, but notice what that does. It changes the signs as everything else goes through. Okay, what is common here? Well, I can see that 4 and a and x, but only to the first power. So if I divide all that by 4 and a and x, and 4 and a and x, that just becomes a big fat 1. And this ones leaves me x squared and then plus 1. And that's where I get. So I'm learning to find the greatest common factor and then factor it out. And what I'm really interested in is this remainder. Eventually, that's what we're going to be really interested in, is what's remaining. Okay, in this one, I can see that there's a 3 in both of those. There's also an x. Can only use x to the first power. And then there is a y squared. So what does that leave? That leaves us an x here and a minus 2 there. And it would factor like that. Okay, on this one, I'm seeing 14, 7, and 21. Well, they all have a greatest common factor of 7. And they all have b's, and they all have y's. In fact, our greatest common factor. And there's a negative on my leading term. So I'm going to factor out a negative 7, b to the first, y to the first. And what would be left over then? Well, 2y squared plus b minus 3y. And if you have to, make sure you just write it underneath and do the problem. That gives me the positive 2. That becomes a 1. That leaves me y squared. Okay, so if you have to, just write it underneath to help you see it. And that'll help you get to where you need to be. We're really concerned with what's left over after we factor it out. All right, and the fourth one, 13, 3, and 4. Well, there are no common factors there, but I do have a's in both of them. In fact, a to the fourth looks like I could use that. And I do have b's in both of, oh wait, a to the second. Oh, I can only use a to the second. Right here, that's the least exponent there. B to the fifth, no, B to the third, I could use B to the third. So a to the second, B to the third is my greatest common factor. And what's left over? A to the 13, a set to the second, b squared, minus 3b to the sixth, minus 4a to the fourth. And here's my GCF. GCF, get used to that term, because that's going to be the first thing that we do every time we factor is look for a GCF. All right, now this one gets a little bit unique. We're looking for factors that they have that are the same. In this first one here, I have the factor of 3x squared times the factor of 5x plus 1. And in the second section here, I have the factor of a negative 2 times the factor of 5x plus 1. What factor do these guys have in common? Well, if you notice, they both have a 5x plus 1. So if I factor that out, what's left over? That will cancel this whole parenthesis. And that whole parenthesis. And what's left? 3x squared and a minus 2. And this is basically how we're going to be getting to factoring by grouping. We're going to be employing this skill, looking for, instead of like, we're looking for binomials that are common factors. That's really what we're looking for, is a binomial that's a common factor. Okay, what do you see as a common factor here? And I'm going to just hint to you that there is actually a 1 timesing this, isn't there? So there is a factor of 7a and 2x minus 3 and 1 and 2x minus 3. What one is common for them both? It would be this one, right? That's the one that's common for them both. So they factor that out. And what's left over? When we factor it out, it basically goes away. So what's left over? 7a plus 1. This is how we start grouping, factoring by grouping. All right, now we're getting to the real meat and potatoes of factoring by grouping. So I look at this and I go, well, the first term is 5x. The first term is xy. The second term is 5x. The third term is 3y. And the fourth term is 15. And not all 4 of them have the same thing in common. But I'm going to do something. What if I grouped these 2 together? And I grouped these 2 together. And now I just look at them in their groups. Do these 2 in a group have anything in common? And the answer is, it's yes, x. So I'm going to factor out the x. And that leaves me y plus 5. Now I'm going to do that to the same one over here. Do 3y and 15 have anything, a factor in common? The answer is yes, it's 3. And what will that leave me? Y. 15 divided by 3 is 5. Now, here we are. What do we have common here now? Now we do have a cofactor that's common. It happens to be y plus 5 and y plus 5, right? So we're going to factor that out. I'm going to keep it in its parentheses. And what's left over after this is factored out? X plus 3. I'm concerned about the leftovers, okay? And there I have factored that by grouping. So first I had to make grouping symbols with the parentheses. Then I looked for something that was common within just that parenthesis, factored it out. And it just so happened that when I did that, these showed up being common in both, didn't they? And then I could factor that, and whatever was left over was my other factor. All right, let's do this. And what if I grouped these two together? And I grouped these two together. Well, what's common here is just 1x. So I'll factor it out, and what would be left? X minus y. And if I did this one, what could I factor out? It looks like a -5. I could factor out a -5, and if I do that, let's just show you, I have a -5 and a -5. What's left over? Because the negatives will cancel. I'm left over with x and minus y. And now look, I have an x minus y common in both. I can factor that out. And now that it's factored out, what's left over? X minus 5. And that is my second factor. And you notice that I'm ending up with two factors, aren't I? The factors for this polynomial are x minus y and x minus 5. And you can see that's why this is why I factored out the -5, so that I could get the right factor, x minus y. All right, here's another one. If I grouped them here and I grouped here, what's common in both these? Well, x, leaving us an x plus a. And over here, what's common? A 3. That leaves us an x plus y. Nope, nothing common there. So maybe what I'll do is just try rearranging them and see if I can find something. So instead of those, how about I'm going to group these two together. No, that won't work. Let's see. And I look and I'm like, well, I tried these two. That didn't work. And if I try grouping these two together, and then like ax plus 3x and x squared plus 3y, in this one I get a x, but in this one there's nothing in common, so that doesn't work. And then I'm thinking, well, what, because I've tried it with this. What if I tried it with this? And I'm going to see that any combination that I try, there won't be something to factor it out. And so the answer there is that it's not factorable. Okay? All right, one more here. So I'm going to group these two together. And I'm going to group these two together. And these two have a x. And this one just has a y plus 5. But would you agree that I could say it's also being multiplied by 1? Does that change that any? No. And so I actually can see that they have a common factor. Sorry, this was y plus 5. It's y plus 5. And when I do that, what's left over? Well, x and that 1 that's there. So sometimes you have to remember there's a 1 multiplying it when you can start to see that, oh, I do have common factors. if that's being multiplied by 1. And that would be the way to factor by grouping on that one. Okay, how about this one? What could I convex together? If I group these two together, they don't have anything in common, so I don't want to group those two. But what if I grouped 5xy with the minus 3vy? They would both have a v, or I mean a y. And then I could also do 6uv with minus 10ux. Let's see if I can find anything there. Okay, so 5xy minus 3vy is a y that will come out, leaving me 5x minus 3v. And over here, it looks like I could find well, it looks like a 2 for sure. How about, I'm going to try 2. And that would leave, and a u, a 2u. That would leave me 3v minus 5x. Well, that's not quite the same, is it? But what if I did this then? What if I factored out a negative 2u? Then that would give me a negative 3v and a positive 5x. And then I could just rewrite this as 5x minus 3v. And this here. And now I do have a common binomial term right here. So I could factor that out. And what's left over is y minus 2u. And that would be my solution. I have broken it down into its 2 Lego parts. These were its factors so that I could construct this. So that's what they do. They kind of move things around so that they can do it. And they notice that, oh, I've got to have opposites. So if I factored out a negative 2u instead, it would work. And sure enough, it works. And there we have our answer. So we're going to try this. So pause the video and see what you can come up with. All right, let's try this. Looks like on this first one, the only thing that's common is a 2, and that would leave me x minus 8. What's common here is a 7, an a, and an x. So what would be left over? Well, it looks like an x, and 7ax divided by 7ax is just 1. Let's do 2. Looks like I have a negative 5x. If I factor that out, that leaves me with x plus 1. And you can check just by redistributing to see if you get back there. On this one, I have an a to the 4th, a b to the 5th, a to the 3rd, b to the 2nd, a to the 3rd, b to the 3rd. So it looks like I could use an a to the 3rd and a b to the 2nd. That's the highest power I could use. So that would leave an a, b to the 3rd, plus 2 minus b. It looks like that's what would be left over. And you could try doing that out the longhand way. Number 5. It's open. Oh, never mind. Hold on. Take a pause here. All right. We've got 9x squared y squared plus 12x squared y minus 6x squared. What I do know is they both have a 3 in common. So, and they all have, oh, there's no y over here, so I can't factor out a y, but I can factor out a x squared. So what will that leave here? That will leave 3y squared. And right here, that's 12 divided by 3 is 4y. And then minus 6 divided by 3x squared is just going to be minus 2. And over here, I can see that I have a binomial that's common. I'll factor it out. And that leaves me with 6a to the 3rd. And remember, there's a 1 here. if nothing else, so it -1. And finally, over here, factor by grouping, I'll put these two together, and I'll put these two together, and I get 5. That's going to be x plus 7. And if I factor out a negative y, that leaves me x plus 7. And then my x plus 7 is my common monomial or binomial term. And I factor that out, and it leaves me 5 minus y in return. And there I have it. Factoring by grouping, finding the GCF. The GCF is our big guy, big thing that we're looking for today. So get practicing learning how to find the GCF. And good luck on your assignment. Make sure you contact me if you have any questions. Have a good day.